Okay, so we've started to talk a little bit about energy, and we've even looked at a unit of energy called joules, which is used to measure energy. But before we go too far, I want to talk a little bit more about what energy is. And I want to understand energy well enough to differentiate between energy and power, because these two terms mean very different things in the physical world, and that will be important to calculations that we go into in class. And by the end of the video, I also want us to look at some of the units which are used to measure energy and power so that we're comfortable using those units during class. Okay, and so the first important concept here is energy. So energy, if we want to define it simply, energy is just the ability to create motion. It's a category of stuff and ways that are able to create motion. So if this is me and I have moving arms and legs, those moving arms and legs have energy because they have the ability to push a box forward. They have the ability to create motion in a box that I'm pushing with my moving body. Okay? And similarly, lifting. Lifting is a form of energy, right? Because if I lift a lifted box, a certain height has a certain amount of energy because if you release it, it's able to fall. And if it's falling, it has motion. So lifting a lifted box has energy contained in it, a form of stored energy called potential energy, which you've probably seen in early physics classes. There's electromagnetic energy. Okay, so if I draw a magnet here, this is like an old school horseshoe-shaped magnet, and now I have a magnetic box, and that magnet is pulling the magnetic box towards the magnet. There's energy contained in that magnetic field because that attractive force actually has the ability to create motion. And if I draw a little chunk of coal here and I light that coal on fire, that coal has stored chemical energy in it because when I light it on fire, it's able to impart motion in the air molecules all around it, right? Heat coming off of that burning coal is actually just very quickly moving air molecules. And when you burn the coal, it has that ability to impart motion into the air molecules, into the environment around it, right? So coal has energy, is a form of energy, or chemical energy is a form of energy. Light is a form of energy as well, because light can be absorbed by small charged particles like electrons and cause them to go whipping around. There's stuff like nuclear energy, where energy is stored in unstable isotopes, radioactive isotopes. Waves have energy because moving waves can create motion in other things. Wind can have energy. All of this is energy because all of these are ways of creating motion in other things. Okay, so energy is just this broad, abstract category of stuff that can create motion. The amount of motion that it can create is oftentimes measured in joules, and so joules are a unit of energy. Okay, now I'm going to draw something else for you. I'm going to do my best to draw a light bulb here. There we go. There's a little filament in there, and this light bulb is giving off light. And as we discussed earlier, light is a form of energy. Okay, so what if I asked you the question, how much energy is this light bulb giving off? Or I could also ask, how much energy is this light bulb consuming? Because those two values are related. But the important thing here is that's kind of an unanswerable question, right? A certain amount of light contains a certain amount of energy. So the amount of energy coming off this light bulb depends on how long the light bulb is turned on, right? A light bulb will give off more energy if it's being lit for 7 days than it will if it's only being turned on for 15 minutes or so, right? So maybe a better way of describing this light bulb is a rate of energy use. In other words, maybe we want to know not the number of joules that the light bulb is consuming or emitting. Maybe what we want to know are the number of joules per second that the light bulb is consuming or emitting. Okay, so we have a rate of energy use, and the total amount of energy used or produced by the light bulb will depend on how long it's turned on. Okay, so joules per second is a new idea here. Okay, well, joules per second also has another name. Sometimes instead of writing the J and then the divide sign and then the S, it's just easier to write a capital W, which stands for watts. Okay, watt is the same thing as a joule per second, and both of these are measures of power, okay? So while energy is a certain amount of these things called joules, which correspond to a certain amount of motion, power corresponds to a certain number of joules per second, or a rate of energy consumption or production. Okay, and that's the big difference between energy and power. Energy is a certain amount of this stuff called motion. Power is a flow of energy. Okay. In addition to watts, there's also units of power that we use to measure big power producers and consumers. Okay, so for example, here's a power plant. Here's a power plant producing lots of power. It might produce enough power for several houses, or maybe like one house, in which case it's producing maybe several kilowatts of power, okay, which is just 1,000 watts. That's pretty straightforward. Another important unit is a gigawatt, because gigawatts are oftentimes the unit of power that power plants are producing to support something like a city. Okay, so kilowatts and gigawatts related to watts, both units of power. Okay, now here's another question. How much energy will a 1 kilowatt power plant produce over the course of 1 hour? So we've got 1 kilowatt and 1 hour. Okay, well, one thing that we could do is we could convert these kilowatts back to joules per second if we wanted to, and we could convert the number of hours to the number of seconds in the hour. And if we multiplied those numbers, we'd be multiplying units of joules per second times seconds, and we would end up with a certain number of joules. Okay? But that's kind of a pain in the butt, especially when everything on the scale of like a house or a city is measured in units of kilowatts and hours. So what city planners and engineers did is they just said, let's define a new unit of power that's just a kilowatt times an hour. Actually, it's defined as the amount of energy consumed by 1 kilowatt over the course of 1 hour, and we'll call it 1 kilowatt hour. So that's a kWh. Pardon my bad handwriting there. Okay. And if we wanted to convert kilowatt hours to joules, we could actually go through the process I described earlier, where we convert the kilowatts to joules per second, and we convert the hours to seconds, and we'd find out that 1 kilowatt hour is actually equal to 3,600,000 joules. Okay. But the important thing here is that we have a large unit of energy here, which is actually useful on the scale of measuring things like homes and solar panel arrays and cars and things like that, okay? And it's a little bit confusing because, as we discussed before, things like watts, kilowatts, and gigawatts, which all contain the word watts, are all units of power. They all describe flows of energy. But a kilowatt hour, even though it still has the word watt in it, is actually a measure of energy. It's a large unit of energy. Okay. In addition, there's a couple other units of energy that I'd like to introduce just so that you've seen them before we get into class. There's a unit called a BTU. It's called a British thermal unit. Okay. And this is oftentimes what's used to measure heating, like the heating demands of a house, for example, or the amount of heat removed by an air conditioner. These are oftentimes measured in BTUs, okay? And 1 BTU is equal to 1,055 joules, just about. And there's another unit of BTUs, which is used more for measuring heat demands of like an entire city, or the heat contained in the coal burned by a power plant or something like that. And this is 1,000,000 BTUs, but it's written really weird. They write like little m BTU. So MMBTU means 1,000,000 BTUs, and it's the same thing as 1,000,000, which is 10 to the 6 BTUs. So we could get back to joules if we wanted to use this conversion factor here. Okay, I think that's just about it for this video. We've got a couple other units of energy that we might discuss during class, but these are some really important ones that you will certainly see later on in life when you're dealing with utility bills and potentially doing cool environmental things like calculating carbon footprints. But the important concepts that I want you to take home from this video is that energy is this amount of stuff that's able to do useful things in society, and power is a flow of energy. It's the amount of energy that's either being consumed or produced per unit time. And so it actually means something very different than energy, even though we use those two terms interchangeably. Okay, we'll end this video there, and I'll see you in class.